Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I have discussed numericals based on chemical equation up to question number 273. Now I will continue from the question number 274. These questions are these are the numericals which are important for A.I.M.S, Iitjee, JEE and Neet examination. Now I will discuss. Keep paper and pen with you so that you can solve it easily. Now I am reading the question. Question number 274. The mass of oxygen that would be required to produce enough CO, means carbon monoxide, which completely reduces 1.6 kg Fe2O3 at atomic mass of Fe is equal to 56. It is given. 4 options are there. First option 250 gram, 240 gram. Second option 480 gram. Third option 720 gram. Fourth option 960 gram. Again I am reading one more time question. The mass of oxygen that would be required to produce enough carbon monoxide which completely reduces 1.6 kg Fe2O3 is. Atomic mass of Fe is given 56. First option 240 gram. Second 480 gram. Third 720 gram. Fourth 960 gram. You have to calculate mass of oxygen that would be required to produce enough carbon monoxide which completely reduces 1.6 kg Fe2O3. Think. Question is little difficult, but you can solve it. Just to think. Here you have to write reaction between carbon and oxygen. Okay. Then carbon and oxygen, it will give carbon monoxide. 2C plus O2, it will give 2CO. And this CO must neutralize Fe2O3. Means it should completely react with Fe2O3. Means you have to write the reaction between carbon monoxide and Fe2O3. Then you will get 2Fe plus 3CO2. Means first reaction you have to write 2C plus O2, balanced equation. You will get 2CO. Correct? Second reaction, this CO plus Fe2O3. You have to write the reaction. Then this will be balanced equation for this 3CO plus Fe2O3. It will give you 2Fe plus 3CO2. Now you got the CO2. Okay. Now what you have to write? Now you have to write reaction between carbon and oxygen. Carbon and oxygen 6. Actually you have to balance it. Balance it means here CO must be cancelled. First two reaction, that both CO must be cancelled. Then first reaction you multiply by 3 and second reaction you multiply by 2. Then in both cases you will get 6 CO. In both cases you will get 6 CO. Then CO and CO will be cancelled out. Correct? Then you will get remaining, you can say after the cancelling you will get, after adding both equations, 6C plus 3O2. That will give 2Fe2O3. And this 2Fe2O3, that will give you 4Fe plus 6CO2. Okay. After adding both equation 1 and equation 2. Equation 1 is 2C plus O2, 2CO. And this CO further it will react with Fe2O3. Correct? This CO will react with Fe2O3. Then you will get 2Fe plus 3CO2. Then you have to cancel this CO. Why? Because according to the question, mass of oxygen you have to calculate, that would be required to produce enough carbon monoxide. Correct? That's why carbon monoxide must be cancelled out. Okay. You have to calculate mass of oxygen. That would be required to produce enough CO which completely reduce 1.6 kg Fe2O3. That's why CO you have to cancel. Then you will get after cancelling, first equation you have to multiply by 3. Second equation you have to multiply by 2. Second equation is 3CO plus Fe2O3. You will get 2Fe plus 3CO2. After cancelling CO, you will get 6 carbon plus 3O2. That will give you 4Fe plus 6CO2. Correct? 6 carbon plus 3O2 plus 2Fe2O3. That will give 3 reacted. Now it will remain left hand side you will get 6 carbon plus 3O2 plus 2Fe2O3, and right side you will get 4Fe plus 6CO2. After that you have to calculate. 3O2 means 3 into 32, that is the 96 kg. In kg directly you can write 3 into 32, that is 96 gram. You can write in, if you want to write in kg, that is 96 kg. And how much Fe2O3 require? Then Fe2 56 into 2 plus oxygen means O3 16 into 3 48. After adding you will get 48 plus 12, you will get 60, 160 into 2 because 2 Fe2O3 is there. Then 320 kg. It means for 320 kg Fe2O3 you require 96 kg oxygen. This is a starting point. For 320 kg Fe2O3 you require 96 kg O2. Means 320 kg Fe2O3 requires O2. How much? 96 kg. Then for 1.6 kg Fe2O3. Then you will get 96 divided by 320 into 1.6. You will get, after solving, you will get 0.48 kg. 0.48 kg, or in gram 480 gram. 0.48 kg into 1000. Correct? You will get 480 gram. In gram you can write 480 gram. Then this is the oxygen, amount of oxygen required to neutralize 1.6 Fe2O3. Hence, correct answer is B, 480 gram. 480 gram. Correct option is B. Now, next question I am telling you. 4.35 gram of a sample of pyrolusite means MnO2 when heated with conc HCl gave chlorine. The chlorine when passed through potassium iodide solution liberated 6.35 gram of iodine. The percentage purity of the pyrolusite sample is first option 40, second option 50, third option 60, fourth option 70. Again one more time question I am reading. 4.35 gram of sample of pyrolusite means MnO2 when heated with conc HCl gave chlorine. The chlorine when passed through potassium iodide solution liberated 6.35 gram of iodine. The percentage purity of the pyrolusite sample is first option 40, second option 50, third option 60, fourth option 70. Just you think. Here also you have to write the reaction. Okay. Then reaction you will write MnO2 plus 4HCl. How much chlorine it is giving? First you have to see. You have to see how much oxygen it is giving. Reaction first to write MnO2 plus 4HCl. It will give MnCl2 plus 2H2O plus Cl2. Now this Cl2 will react with potassium iodide and it will produce iodine. Okay, that reaction you have to write. Then 2Ki plus Cl2 you got from the first reaction chlorine. That chlorine will react with Ki and it will produce iodine. Means balanced equation is 2Ki plus Cl2. You will get 2KCl plus I2. Now this iodine, this one more reaction actually you have to write, then you can solve it. Then that reaction is between, now you can do both reaction first to add. For both reaction you add it. Then you will get MnO2 plus 4HCl plus 2Ki. Correct? Cl to Cl is going to be cancelled. Okay. Cl2, equation 1, equation 2, if you add Cl2 will be cancelled. Then remaining will, what will remain? Then MnO2 plus 4HCl plus 2Ki and right side you will get MnCl2 plus 2KCl plus 2H2O plus I2. This you will get. Then MnO2 means, what is the molecular mass? Mn means 55 atomic mass and oxygen means MnO2 32 means total will become 87 gram. Then MnO2 is giving 254 gram. Iodine molecular mass is how much? 127 into 2, 254 gram. Then 87 means 254 gram iodine you are getting from 87 gram MnO2, pure MnO2. Okay. 254 gram iodine you are getting from pure 87 gram MnO2. Then for 1 then for 6.35 gram iodine. Then 254 gram iodine is giving 87 gram MnO2, pure MnO2. Then for 1 it will be 87 divided by 254, then for 6.35 into 6.35 MnO. This is the quantity of MnO2. After solving, you will get 2.175 gram MnO2. Then now purity you have to calculate. For 6 gram, 6.35 gram iodine. This iodine you will get from 2.175 gram pure MnO2. Then percentage purity you can calculate that 4.35 gram according to the question. 4.35 gram sample of pyrolusite when heated with conch HCl gave chlorine. The chlorine when passed through potassium iodide solution liberated 6.35 gram of iodine. You have to calculate percentage purity of pyrolusite sample. Then now 4.35 gram sample. For that you have to calculate 4.35 gram pyrolusite. Okay, that gives 2.175 gram these things. In this you can tell that you calculated MnO2, that is the pure MnO2. Correct? 2.175 gram you got pure MnO2. Then this pure MnO2 you got from 4.35 impure MnO2. This is important here. This 2.175 gram pure MnO2 you got from 4.35 impure MnO2. Then what is its percentage? Then 2.175 divided by 4.35 into 100, because 4.35 gives a 2.175 pure MnO2. Then for 1, then for 100, then you will get 2.175 divided by 4.35 into 100. After solving you will get 50 means that is the purity is percentage purity is 50%. Means 4.35 gram. That was the impure MnO2 that has given 2.175 gram pure MnO2. Hence its percentage is 50%. Okay. Hence correct option is B. 4 option was there, 40, second option 50, third 60, fourth 70. And now you got correct 50%. That is option B is correct. Now next question I am discussing. Minimum volume of SO2 gas at STP which reduces 100 ml of 0.1 N K2Cr2O7 is first option 11.2 ml, second option 22.4 ml, third option 40 ml, fourth option 112 ml. Again I am reading one more time. Minimum volume of SO2 gas at STP which reduces 100 ml of 0.1 N K2Cr2O7 is first option 11.2 ml, second option 22.4 ml, third option 40 ml, fourth option 112 ml. Just to think, for this reaction also you have to write equation. So it is based on chemical equation. Hence, always you have to think for the reaction. That is the basis for calculation. Now, just to think. Now, I am giving you hint. K2Cr2O7 plus H2SO4, actually acidic medium, means K2Cr27 balanced equation will be plus 4H2SO4. K2Cr2O7 plus 4H2SO4, it gives a K2SO4 plus Cr2SO4 whole 3 plus 4H2O plus 3O, nascent oxygen. Now, this nascent oxygen will react with SO2 plus H2O, okay, and it will give H2SO4. Then now, equation 1 and equation 2, that you have to add it, okay. K2Cr2O7 plus 4H2SO4, it gives K2SO4 plus Cr2SO4 whole 3 plus 4H2O plus 3O. Now, this 3O, what you got, oxygen, nascent oxygen, that will react with SO2. SO2 plus O plus H2O, it will give H2SO4. Then now O must be cancelled. You have to cancel it. Then for that purpose, equation 1 and now SO2 plus O plus H2O, it is giving H2SO4. Then actually in the first equation you got 3O. Then here also it should be 3O. That's why second equation also you have to multiply by 3 and then you add it. Then oxygen will be cancelled. 3O will be cancelled. Then what you will get? What we will get finally after adding? Then you will get K2Cr2O7 plus H2SO4 plus 3SO2. Okay. This left hand side you will get this, and right side you will get K2SO4 plus Cr2SO4 whole 3 plus 4H2O. That here left side only you have to consider. K2Cr2O7, that is molecular mass you can calculate. K2 39 into 2 78, Cr2 that is a 104. Okay, 104 means 52. Chromium atomic mass is 52, then 52 into 2, 104, and O7, then 7 into 16, you will get 112. Total you will get 294 kg in term of kg. In kg you will get 294 molecular mass. Then this will completely react with 3SO2 according to the equation. Then 3SO2 means 3 into 1 mole means 22,400 ml. Then how much? Because it is a gas, that's why you are writing in volume. Okay. Then 3 mole means 3 into 22,400 ml. Then now you just to calculate for 100 ml 0.1 N K2Cr2O7. Okay. Then 100 ml of 0.1 N K2Cr2O7 means how much? Then 4.9 divided by 1000 into 100 gram. That is the meaning of 100 ml 0.1 N K2Cr2O7. K2Cr2O7, its normality is 49, you know. Then 0.1 N means 4.9. Then this is present in 1000 ml. 0.1 N K2Cr2O7, K2Cr2O7, its normality is 49, you remember. For 1 N, then for 0.1 N, 4.9, then 4.9 gram must be present in 1000 ml. Means 1000 ml contains 4.9 gram potassium dichromate. Then for 1, then for 100. Then you will get 4.9 divided by 1000 into 100. You will get 4.9 gram. 0.49 gram. Okay. Then now easily you can calculate meaning of how much potassium dichromate is present in 100 ml. Now you calculated 0.49 gram. Then now according to the reaction what you have calculated, the equation, balanced equation final, from that now you have just seen that 294 kg gives 3 mole of SO2, means 3 into 22,400 ml SO2. Then for 1, then for 0.49 potassium dichromate. Then you will get 3 into 22,400 divided by 294 into 0.49. After solving, you will get 112 ml SO2. Means 0.49 gram K2Cr27 will give 112 ml SO2. Correct? This is the correct answer. Then now its correct option will be option D, 112 ml. 112 ml. This is a fully based on a chemical reaction, because that you have to calculate minimum volume of SO2 gas at STP, which reduces 100 ml of 0.1 N K2Cr2O7. Then first you have to find out how much you can say this in 100 ml, how much how much gas you will get. Then you calculated that this things 0.49 gram K2Cr27 is present in 100 ml 0.1 N K2Cr27. Then reaction you have written to further calculation, because 294 kg gives 3 into 22,400 ml 3 into 22,400 ml SO2. Then for 1 and then for 0.49. Answer you will get 112 ml. Hence correct answer is option D, 112 ml. One more question I want to discuss. Question number 277. In Haber process, gaseous nitrogen and hydrogen react to form ammonia, whose volume of reactants would be at NTP would be first 1/4, second 1/2, third the same, fourth 3/4. Again one more time question I am reading. In Haber process, gaseous nitrogen and hydrogen react to form ammonia, whose volume of reactants would be first 1/4, second 1/2, third the same, fourth 3/4. Okay, just you think. Here reaction you have to write, then easily you can write. This is very common and easy. This you can solve it easily. Okay, you have to understand the question. In Haber process, gaseous nitrogen and hydrogen react to form ammonia, whose volume of reactants would be That is the first option, 1/4, second 1/2, third same, and fourth 3/4. Okay. Then reaction you write N2 plus 3H2, that is the 2NH3. Then 1 volume nitrogen and 3 volume hydrogen is giving 2 volume ammonia. N2 plus 3H2, you are getting 2NH3. 1 volume NO2, 3 volume H2, total 4 volume is giving 2 volume NH3. Correct? Then volume of products NH3, that is a 50% of the reactant, means half into volume of reactants, half. Hence correct option is 1/2 B. Because 4 reactants are giving 4 volume is giving 2 volume. N2 plus 3H2, total 4 volume. 1 volume N2, 3 volume hydrogen, total 4 volume. And you are getting 2 NH3, means 2 volume. That is a 50%. Hence that is the 1/2. Hence correct option is B, 1/2. Now I am stopping only here. Thank you. Next class again I will meet you.